Right.
Did we disable end-to-end encryption on our Zoom calls by default? I used to always see the green lock, and I don't these days.
I don't know. That's a good question for Jesse. We are also recording now. Let me check on that one.
In this case, it's fine. It doesn't need to be encrypted.
Well, I think this one will be public eventually, so yeah.
Yeah, they're all published. I didn't know that they are encrypted by default anyways.
I don't know if they are. You have to enable it, but we used to do that. It provides a larger anonymity set for people who do need encrypted Zoom calls, so I'm in favor of doing it, even if we don't require it in that particular instance. Cool. So just a quick reminder that ICSs 2, 3, 23, 24, and 25 can be reviewed. 23 and 24 are more or less done. Same with 2, I guess modulo some comments already. 3 and 25 are still kind of in final draft stages, but it's still helpful to review them if you haven't taken a look yet. In particular, 25 will see some revisions based on some discussions we had on Tuesday. I also want to mention that I finished earlier today, in response to a request from Peng, who's working on a section on our website about IBC, just a quick list of broadly specified example use cases along with kind of what kinds of packets they would send over IBC, which can also be something to keep in mind as we construct the protocol. And that can be also reviewed, and anyone is welcome to add things they want to list to this pull request, which will just edit a markdown file in the repository. I also wanted to note that we are going to try to start a first MVP implementation next week when we finish up the ICSs through 5, which should be done by mid next week. That will be implemented by June, who will be leading it with some help from me and help from lots of SDK reviewers as a module in the Cosmos SDK. And we're aiming to have that ready for use by the hackathon at the Interchain Conversations event, which is mid-June. It's like June 15th or something. So have that done in about a month and 2 weeks or so. I am not sure. That will contain all of the sort of essential IBC logic, connections, channels, and packets. I am not sure what complexity of light client it will contain. I think that's second priority to giving application developers a chance to play around with the interface, which should be finalized more or less by that point. So we will have hopefully some simple light client, but probably not fancy things like bisection. Any questions about that? So that will be probably a PR to the SDK repository or to the SDK repository, not the ICS repository, but we'll link to it.
And that will be implemented in Go?
In Go, that's right.
On the light client stuff, I think that the stuff Zachy and Jay and I were working on does have bisection.
That is right, but it was my understanding that that would not work for IBC because...
Oh, okay. Yeah, I think that there is a little bit of additional work to be done for IBC, but we could likely reuse a lot of that same logic to do the bisection for IBC. So.
Okay, Zaki said he thought reusing it would be hard, but I'm strongly in favor of reusing it if it's not hard.
Can I quickly ask why it's not, like what is it, what is not used in IBC of that like pull request?
I mean, so the light client in Tendermint makes a bunch of network requests, and its job is to sync to a root of trust, or the latest root of trust, or the root of trust for some particular block or transaction, given a known root of trust. Whereas the light client in IBC just verifies headers. And in a sense, it's simpler. It can't make network requests. That's the job of the relayer submitting new headers to the blockchain via transactions.
Okay.
So on-chain IBC client, all it needs to do is keep some current root of trust, maybe a list of the last, headers, the last 50 blocks or something, and then accept updated headers that are valid. And all of the logic for determining which headers to fetch and when to submit them is up to the relayer. All the light client needs to do is validate them.
So IBC might use the verification logic.
Ideally, IBC would use the verification logic, and then sort of network fetch logic would be split out, and then the network fetch logic could be in fact, just directly included in an IBC relay or binary application down the line.
Okay, that
thanks.
makes a lot
That
more
was very
sense.
helpful. Thanks.
Yeah, we could probably reuse some of that logic in the binary relayer application because it's going to be essentially the same, but interesting to know. Thank you, Chris.
Cool. Now I'll open the floor up to discussion. That's all. Those are all the official agenda items this week. Some things we could talk about if you're interested or it would be helpful to go over are the sort of interface that will be exposed to modules by the IBC handler. We could talk about the requirements of state machines in ICS 24. We could talk about, I think everyone on this call has been to IBC calls before. Who is Maine? Maine?
Hey, sorry, I could do a better job. I need to figure out how to rename myself. I think I made this over. But this is Ray from Oasis Labs.
Oh, hey, Ray.
Oh, great.
Welcome.
Yeah, thanks. Thanks for inviting me. Sorry I haven't been able to join some of the earlier ones, but I wanted to sit in and check out how
No
things
problem. Can you briefly, for the participants on this call, myself and posterity, introduce Oasis and explain your interest in IBC?
Yeah, so Jack and I have been talking for a little while, and so just a quick briefer on Oasis Labs. We're launching a layer 1 blockchain. We have a novel scalability architecture, but one of our main core value propositions. Oh, sorry. I think the fire alarm just went off in my building.
Oh no! Well, if there's a fire, don't stay on the call.
For your own sake, I'm gonna mute myself for now.
Yeah, absolutely.
Oh my.
Okay, we'll come back to the introduction later. Feel free to don't compromise your safety for the sake of this call. It's recorded, so.
Raymond, looking forward to hearing more about Oasis Labs as well. But one potential topic of conversation would be like relayer architecture. That's going to be a separate binary. It's going to be calling in between multiple chains. I've read some of the specifications on this. I would be sort of interested to discuss a little bit more about that.
Sure. So, I mean, I think the questions around relayer architecture to which we will need to devote time are questions about fee payments for IBC sort of actions involving several transactions where we want to minimize the UX load imposed on the user. So if I'm some user sending tokens from one chain to another chain or maybe through multiple chains, some number of actual transactions need to happen. And as a user, I kind of only want to take action once and pay one fee and have it cover all of the transactions. We probably want to come up with, and this isn't really IBC core, it's like a layer on top, but we want to come up with some protocols by which relayers can, say, take an initial fee on one chain and send all the transactions or something. Or relay fees between chains as part of another IBC transaction, which is mostly doing something else.
Pretty easy to imagine something going from a zone connected to the hub to another zone connected to the hub, just a standard 2-hub.
Yeah. So, I mean, to
Also,
clarify...
innovation for people to run relayers as well, correct?
Yeah, I mean, I'm not really convinced that we need to build a complex relayer market architecture because there don't need to be tons of relayers competing for things. In fact, that's probably bad. It will just lead to
the generic solution is usually that the relayer is the user.
Right, that will always work, yeah.
Yeah, what one should expect under sort of normal circumstances is that the relayer is the person who wants to conduct the transaction on multiple chains.
More practical would be to think that the typical relayer is wallet software that has some server that watches over the relays. That's more UX friendly because a lot of time users want to fire and forget, so they don't want to wait for multiple confirmation on multiple chains to know that the transaction is being processed. So they want to push a button and forget about it, and that's where the wallet comes in.
Yeah, that's right. And I think so. If we want the wallet to be able to automate transactions on multiple chains, the tricky part is that all of those chains need to have their own spam prevention mechanisms. They need to charge some sort of fee. And I think one way of having the user only pay a fee once in an asset on a chain that they're sending from is to have them send the parts of the fee through IBC transactions in sequence, and a little part gets doled out to the relayers or doled out to the chain along the way. That's fine. Another method, which maybe is simpler, is to have the validator sets of the other chains which are accepting the transactions themselves have accounts on the chain on which the user is paying the fee, and then the user pays a higher fee that in part goes to those accounts on the first chain, and the validators take that of the other chains, treat that fee with a simple proof over IBC that it's been paid as part of the packet as payment for all of as sufficient fee payment to submit a transaction on that chain, because it still provides the same spam prevention.
Would we need, sorry, Dean.
Yeah. Does that make sense, Saki? As a distinct solution from split up the fee and send it along in all the transactions.
It sounds kind of like a similar solution to some of the interchain collateralization things that we're talking about, like validators have accounts on different chains.
Well, okay, so in the context of interchain collateralization, what we've mostly been talking about is actually having accounts on the chain that represent the staking pool that is sort of manifest as the validator, just to clarify that piece. And we could probably, if we need to go into what that means later. I think one of the challenges is around fees is always been, it's been more like how do you pay fees on multiple, there is work that needs to be done on multiple chains. One or more of those chains may require fees to be paid to get that work done. And a user who wishes to perform that work may not have an account on all of the chains that they interact with. To me, honestly, I actually think the simplest solution to this is actually just literally interledger. To hope for and expect and try to encourage the existence of market makers that hold accounts on multiple chains who expose interledger, the interledger interface, and are just okay, you want to pay, you need to pay fees on this other chain. You could send me money on a chain that you do have money on, and I will make sure that the fee gets paid on this packet.
The scenario that sounds interesting and plausible to me too. The scenario that that I want to understand here is, in the case of a user invoking a transaction that causes interesting work to happen, where by interesting work I mean, work on one chain happens to have bought a right on another chain that uses a service on yet a third chain, it doesn't take very much actual composability or actual dynamic market activity, so that the user neither knows nor cares on what chain all of the work is happening in order to make his or her dream come true here. And so the idea that it's the user that is causing the relaying to happen seems implausible to me, because that assumes the user has any idea that it's, Joe's trucking network that is the one that's being paid automatically to ship the new good that he just bought at an auction, at Jane's eBay clone or whatever, right? And so is that just more advanced scenarios I'm talking about, or am I misunderstanding where the driver for relaying comes from?
No, I think that's right, but I don't see it as being a substantial. I do think it's a more advanced scenario, and I don't see it as being a substantially different problem. I mean, in that case, we're just talking about different users who care, right? The original user doesn't care, but May's eBay clone or whatever you called it is going to have to pay the fee to subcontract to Joe's Trucking for delivery, right? So someone has to pay a fee.
That's right. Yeah. Well, so the question is whether, my terrible examples, whether May's auction, paying Joe's Trucking, pays a fee for the trucking. The question of whether May's auction is also paying the relay fee, or whether relayers are third-party services like validators that have an incentive to do the shuffling because they're going to make money as a result, right? Here's a message from May's machine to Joe's machine. Both of them were connected to the network. The transport of that costs, 1 quatlu, and so a relayer picks it up, for spam prevention, puts in 1/4 of a quatlu to submit it, and gets back 1.5 quatlus as a reward, or whatever it is. Some structure so that the people that are actually gluing these networks together have an incentive to do so proactively and efficiently.
I think that was kind of my question too, Dean. Well said. Also, I like the trucking company better than Bob and Alice.
Yes, I'm trying to move us off of Alice, Bob, and Carol. But
yeah, in the space of things we're considering here, I also think it's worth noting that it's not necessarily the case that all chains will require computational proportional fees. That's a very necessary feature for Ethereum, and it's also a necessary feature, although it's proportional to storage instead of computation for Bitcoin, for example. But some chains might just be able to perform validation cheaply enough on the input transactions that they don't need to. Like a DEX could accept incoming liquidity that checks out proof-wise, conceivably without charging any fees, and that doesn't seem super problematic, although there might be fees for other actions like trading. So sometimes it may not be so much of a difficult problem to solve. But it sounds like there's sort of two classes of approaches. One class of approach puts the payments in the protocol and has relayer, and this class makes it pretty easy to have a market of relayers, any of whom could pay the actual fees, because the person who is sending the transactions or the later on intermediary agent who is initiating the subsidiary transactions marks some fee on the chain which they start out on to be allocated to some relayer which needs to get to them when they in fact relay the transactions that the user wants to be relayed. But another class of approaches, which is like what Zaki's talking about, would instead have some out-of-band payment occur that's more likely, as I understand it, to be to a particular relayer, who then the user would expect to relay their transactions in accordance with that fee. In the interledger model, Zaki, is there a way to sort of enforce that the relayer who relays the transaction gets the fee, and that if they're paid the fee, they have to relay the transaction? Is that atomic, or is there some trust involved?
Anything atomic has mostly been removed from the interledger protocol, so typically there is some form of trust involved.
Bounded.
Huh?
Some form of bounded trust involved.
Yeah, some form of bounded trust involved. I'm thinking about these things.
I had a lot of trouble hearing Zaki just now. There was a long delay in the middle of it. I missed some audio. Did anybody else? Is that just me, or did other people hear that too?
Just you.
Just you.
Okay.
So I'm just thinking out loud here. I haven't really fully thought about this, but this is an interesting topic to think a lot about. Fee payment is always, I think, probably the hard problem that emerges from any multi-chain system. I'm feeling like there's some. I'm starting to feel like there's always like kind of like. I'm starting to see a pattern, which is there's a version of the system in which you impose a lot of, or there are higher expectations about what the state machines support on both ends of the connection. And there's a version of the system that makes fewer assumptions about what state machines support on both ends of systems and tends to rely more on layer 2 solutions for fee payment.
Okay. I actually think that there is a much simpler solution that will be popular at first and has some benefits for wallet designers. I think that the most popular thing will be user paying wallet, maybe paying conditionally on their transaction succeeding to the end. And wallet software paying fees out of its own pocket on all the chains that are involved. So user doesn't have an account on any chain but the initiating one. He reserves some payment for the wallet software, and wallet software out of that reserve that is estimated at the moment that transaction is initiated makes transaction a bit like the withdrawal fee on centralized exchange is implemented. That's easy to implement for it, and it has some wallet software incentive built in. That
so to be clear, do you mean that the operator of the wallet, like the person who's hosting the web wallet or something, has accounts on all the chains that their wallet supports, and they charge an extra fee for the initial transaction, then pay the rest of the fees?
Yes.
Okay.
Yeah, it's very, very similar to like the interledger architecture.
Yeah. I feel like what Vasily, is that your name? Sorry. Just said is can be combined with micropayment channels, so that you don't have to have an account on all the chains, but you can still pay from one place, and then you have interledger or other intermediaries that are helping pay on chains where you don't have accounts. And limited trusting is fun to me.
That also potentially provides a monetization mechanism for wallet providers who right now are kind of in a rough competitive position. Could be really cool.
Very cool.
Just a quick technical question. It seems like if I'm on my cell phone, I should be able to like create light clients to the two chains and then perform an IBC transaction as the relayer. There might be additional latency there because I've got to download a bunch of headers and verify both chains, but is that possible?
Yeah, your phone can make a payment and be secure about what it's signing off on. But it would need to sync with some chain within an unbonding period, but that's another story.
Yeah, I think that's
possible to automate all of that. Like if you just, when you create a wallet, send it $5 or something and select a set of chains that you want to relay stuff between. You can kind of just have a balance that's used for paying fees, and it seems plausible that one could write an algorithm that keeps accounts on all these separate chains, which don't need to have particularly secure private keys because you're just storing tiny amounts of funds, and does the relaying for you more or less, like behind the scenes.
That seems common sense.
It's a little more work for the phone, but with Tendermint-like clients or something, it seems totally plausible.
Mm-hmm.
I think that there's additional latency there on the initial setup, and that might deter some users. I think it's just there's multiple approaches to solving this, and like the hosted web wallet solution with potentially better integrated fees is definitely more user friendly. And then this idea of like syncing a phone to multiple light clients and then sort of like having the wallet software handle those fees is just another potential path. I think we should leave as many open there as we can and allow experimentation on business models.
Yeah, I agree. This is pretty auxiliary to like any of the core protocol stuff, so it can change over time.
I think with Yeah, we've identified a lot of ways this could work out, and so it seems like we can classify it as something that can be done after an MVP, maybe.
Yeah, I agree.
These are all the things that are worth thinking about right now.
I've been taking notes on the doc, which anyone is welcome to append to.
Yeah. Yeah, I'm not saying otherwise. I totally agree. I love the conversation.
Yeah, I do too. I think Vasily's point about wallet monetization is interesting.
Yeah, that's a great point.
Yeah.
And it's well suited to like the hopeful eventuality of there being different wallets which support different subsets of the Cosmos network and do different sorts of interchain things. And then they can select, ease the UX for whatever users are expected to do through their wallet. I don't think the trust required there is like substantial enough to be a problem. If the operator fails to relay the transactions, worst case, the user just does it themselves. The worst they can do is not relay or something. They don't have access to any actual custody.
There is also one more thing about the architectures we want to adopt as the default for interchain communication. We want probably to have them as simple as possible, because the Cosmos strong point is that you don't need to do a lot to integrate it into a larger economical ecosystem. And if to deploy your chain in Cosmos, you need to attract like interledger market makers and implement some complex state machine to allow for the most common IBC payment method. It'll make adoption more complex, and it won't be good for Cosmos.
Yeah.
Sorry, could you? I didn't understand. Could you repeat that, please?
I mean that we might want to optimize for simplicity for relayers, for the default method for relayer implementation, because the more complex the relayer is, the harder it is to connect your own zone to a Cosmos ecosystem.
Yeah.
And
yeah. I see. So we have to make it easy, otherwise it'll hurt adoption.
Or specifically, it sounds like avoid requiring that the zone attract other third parties to perform roles which are complex, like interledger market makers.
Yeah. Third parties should only emerge or should be like a market efficiency that emerges like if the amount of interchain traffic is large. And so it becomes like efficient to have specialized actors start coming.
Yeah, but I don't think it's necessarily bad that we require third parties. I almost see it as a benefit. It's like as long as it's reasonable, and I'm not sure what unreasonable means, but like even if it's just there to help pay for fees as directed by a mobile phone, for example, which might lose connectivity, but you might want your transaction seen through. The more reasonable participants, the better. It's like another supporter. Or we can bundle it into the validator software so that it's like optional and at least some people will run it as long as it's profitable. But like I think we can get it to the point pretty quickly where it's all automated and profitable to run, so most people just run
it. The idea of third parties that emerge, the other way to think about that is what are the third parties that would be useful to seed in order to accelerate the amount of cross-chain traffic, right? As opposed to waiting till, there's enough, cross-chain traffic is painful, but valuable enough that people do enough of it that it seems worth optimizing. If it looks architecturally like it is of value, then in order to, grease the wheels of people doing cross-chain work, deploying the right services to make that easier would be of value. So,
Yeah, I
TBD.
agree. But I don't think fee payment is the primary blocker. I mean, like initially cross-chain traffic is going to be demand constrained by the useful things that you can do on different zones for a long time. And then eventually it's going to be supply constrained by throughput of the popular zones, the ability to which they can like segment their operations across concurrently executing blockchains, and I guess the cost of executing, the underlying cost of executing the transactions, which IBC doesn't really, there's no inherent cost to IBC. It just reduces to the cost of whatever the transaction costs are on the constituent chains. Those all seem to be like, to me, like more important and harder to optimize variables than greasing the wheels of fee payment, to be honest. But it's important to think about this too. I just think it's something that we can more or less come up with several different strategies for and make sure they're all viable and let things emerge.
So I guess what I would just like mostly compare and contrast approaches with is like there's some model in which we expect there to be tokens with some semantics that allow some of those tokens to be paid out as fees, like inside of every IBC packet. And then there's a model where we're like in the authenticated data of the datagram. And then there's a model in which we say there are going to be that like chains that want people to pay fees on them will, on the transaction that submits the datagram, there will be some mechanism, they'll have some semantics for attaching fees, and whoever submits that transaction is going to pay those fees. And they're going to need accounts to pay those fees. And if the user party who sort of initiated one side of the datagram sending doesn't have that account, there will be some sort of mechanism provided by either like their wallet provider or someone else, so that they can complete the transaction. Does that make sense? As like what I see as like the two primary options.
Yeah, it does. And it's easy to add like a standard way to wrap a datagram with fees that we can specify in a specification, and can be something that chains optionally implement. Then they sort of support both. Like if you send it with fees, that is, enough. But if you send it without fees, then you need to have some other mechanism for paying the fee. And otherwise, beyond like switching on how the fee will be paid, the rest of the packet is executed the same way.
And then the other variant of sending it with fees is sending it with a reference to an account that fees will be drawn from. If in some sense, there's fees that are to pay for service, and there are fees that are just to deal with congestion, to spam prevention and prioritization in congestion scenarios. And so it might be that you're not attaching the money to the packet, but rather attaching an account reference, assuming an account was already set up in the destination service. So you can just say, yes, this is another one of my things, take the micropennies out of my account. And if you've got a microsense architecture that works, that is, Interledger has some of that kind of thing, as Saki noted.
Hey, I want to make a suggestion, only a suggestion. That's that acknowledging that fees are extremely interesting, but also pretty broad. Talk about something else for a bit, which is I'm curious about how connections are created. Maybe this is in one of the pull requests, Chris. I don't know.
It's in ICS3, but we can totally talk about it.
Okay, cool. Can you can anyone do a verbal quick rundown of how it works?
Yeah, I can do a verbal rundown. So when we talk about connections, we're talking about a connection between two chains. No specific modules need to be involved. Modules get involved at the level of channels.
I just want to clarify that how a connection is made. I mean, specifically the context of the hub or maybe a zone that wants to connect to the hub. When they write their application, Like, how is the connection to the hub specified? I presume.
So they will first need to initialize in their IBC handler a client for the hub, so a light client with some root of trust they start out with. Then they will create like a connection object in the first stage of the connection handshake and relay a packet from their zone to the hub. The packet will provide a proof that they've stored the hub's light client information, and it will provide like a proof of the connection identifier that they want to connect to the hub. The hub will verify that, sorry, datagram, I shouldn't call it a packet because packets are the application level thing. The hub will verify that datagram, as in it will check that it will look at its own root of trust, check that the other chain stored the right root of trust for the hub. It will look at the identifier and look at like the identifier that the other chain is requesting that the connection have on the hub. Then if all of that checks out, the hub will create like connection in progress data structure in its state in the IBC handler, and it will send a confirm packet or an ACK packet back to the zone, providing a proof that it has acknowledged the connection attempt and it has stored the like that it has access to the right light client information for the zone. The zone can verify that proof, and then the connection is open. So the specific thing which that handshake accomplishes beyond just getting the right data on both chains is that it prevents a third chain from like joining in the middle of it and masquerading as one of the two chains. Because the chains have the ability to introspect their own roots of trust, they can check that the other chain actually thinks it's talking to them, not some third party, if that makes sense.
Yeah.
Does that answer your question?
Not sure. So when a zone first starts up from Genesis, it's going to, I suppose it'll start off with no connection. And then, like you said, a connection will be established through a sequence of acknowledgements.
I mean, it could be a Genesis, like in a Genesis transaction or something. It's not really.
Right, but it will be interactive, so that's interesting. And once the connection is established, then I suppose it's some kind of entry in the connection module, IBC module, and yes. I suppose like other keepers in the SDK can reference the IBC module and refer to this connection by what though?
An identifier.
And is it a identifier? They don't have the identifier to start off with. But presumably it's been generated when the connection was made. So I guess the identifier has to be like shared via a parameter.
That's right. I mean, I don't think connections need to be permissioned. So the IBC handler can just expose, channels are permissioned, but the IBC handler can expose a like list of all its connections, and modules can read the list or something. Or users submitting transactions can read the list. If you're asking how a module learns about the identifier.
Like how does the zone know that this connection is the connection for the hub, and so that I don't know, it marks it as like
that sort of depends on the application. Like if the zone starts after the hub, knows it wants to connect to the hub, knows the root of trust for the hub, then there's no reason not to just include all of the required initialization data in the Genesis for the zone. Like include a root of trust for the Cosmos hub and an identifier called hub, or it doesn't have to be human readable, like there could be a separate registry, but some identifier for the connection, and then like, auto connect the bank module when the zone starts. All of that should be possible. But it would also be possible to do it interactively where, after the zone is already running, it decides it wants to connect to another hub, and someone, sends some someone looks up root of trust, someone being like an external processor or a user looks up a root of trust for the new hub, initializes a client and a connection, and then like maybe there could be things that need to be permissioned, like once a connection is initialized, if it's supposed to get special permissions on the bank module or something, like governance might need to approve that or something.
Okay. Sorry, I think I've exhausted the questions I've had. Thanks. I don't know if
Did
you
that
guys
answer
would like to
your
feed.
question?
Yeah, yeah. I see it better now, like how to code looks, and looking forward to seeing how this works out.
The goal is to build for the dynamic setting, because if we build for the dynamic setting where running blockchains are always like creating and destroying clients, connections, channels, etc., it will always work in the static setting because we can just like run the initialization actions in sequence. So we assume that, you know, modules, which could also be smart contracts or could be hub modules, SDK modules, can be like created and destroyed, and they can open channels whenever they want. And it's always up, you know, if zones want to restrict what the IBC handler can do, you know, more restrictively than what the protocol safely allows. That's always safe.
Like I wonder if in a zone it's even necessary to specify that the hub is special, like the Cosmos hub, because I guess I'm starting to see that you don't have to, because all the zones that you connect to, whether it's a hub or not, you can send coins to, and you can expect coins back. And the hub's not really special in any regard, which means if that's true, it has consequences on like how we want maybe to be able to compress coin chain IDs, maybe by numeric index or something, so that like coin representations can be shorter, because every coin's going to have like a source zone.
Yeah, at the protocol level, there is no specific distinction for hubs, but like the Cosmos hub, you know, would have a specific connection identifier on a specific zone, and that specific connection identifier, which validates packets from the hub, and the hub only could be given whatever permissions to, you know, mint atoms, I guess, or mint atom equivalent tokens. So it is special. It's just not special at the protocol level. It's like special by denotation at the outermost channel permissioning level.
Sorry, I don't quite follow how it's special.
I mean, not that the hub in particular is special, but that different connections in IBC can be given permissions to do different things. So it's not the case that all zones connected to another zone like have equal permissions, or even necessarily the case that they can all create tokens. I mean, you could do that. You could allow them to all create tokens.
Yeah. No, that's a fair point. Yeah, but maybe my question is more about how we should implement it for the Cosmos hub to start off with. So maybe the question is, how do we implement it for MVP? Maybe the answer is we start with no special permissions, but that the bank keeper can send tokens through IBC to any connection, and then we'll add like permissioning on top later as we evolve the system. I'm just thinking through the order of implementation.
Yeah, that makes sense to me. I mean, if we set it up so that the Cosmos hub accepts incoming connections and channels from zones to the Cosmos SDK bank module in the hub, and prefixes tokens sent from those zones with like some identifier for the zone, and allows people to send tokens to any zone they want, you know, caveat emptor. That would be cool, because then anyone can start up a new zone, include the hub's like client root of trust, and like just open a connection and start sending tokens, and no governance is required.
Yeah. So I feel like is this what we're gonna start implementing next week? Like the IBC mock module and some kind of, I suppose, usage of it. Probably the bank module would be easy or useful to start mocking up or trying to write the pseudocode for.
Roughly, yes. Not the like initialization logic so much, because we want this more for people at the hackathon who are going to build two zones and then have them talk to each other over IBC. So streamlining, like it's okay if they send a few transactions to initialize the connection, but all of the identifier handling, creating connections, channels, that's what we want to implement. Yeah. Anything else you think it would be good to implement soon, so we understand?
Well, I'm just starting to see that there's a need for two implementation teams. One working on the actual implementation to make it work, and the other on the bank module. And they're kind of independent, although there's an interface. But that's the API that we're creating. And yeah, I'm just trying to figure out how to split the problem into
yeah, that's right. ICS 25 has, it's not done, but it has a fairly explanatory outline of what the API 2 modules will actually look like. And we should already be able to basically say what the properties of that are. So it will already be possible to start constructing what module applications on top of IBC will look like.
Okay. So which part, do we need another engineer to help with implementation, or are both you and June going to work?
For the Cosmos Hub, I mean, sure, it'd be good to have someone else working on it.
I think Ishmael.
I don't think we do, but
I think Ishmael said that he's interested in working on a Rust implementation. Maybe Ishmael.
Yeah, I can. I would love to work with you guys like in parallel. Like let's sync a little bit. So it's fairly easy. All three of us are in Berlin. So if we could get some Rust code that does like a minimal subset of what we need, that's perfect.
Could you work on a Go implementation of the bank module, modify the bank module according to ICS 25 first, and then we'll have, once we're done with that, we should be almost done with IBC and Go, and then we can go back to doing Rust.
Yeah, makes sense.
As far as those bank module changes, is that something that we need to upstream into the hub?
It will be. I would note that I think what we're talking about here is not, I think we can keep the existing bank module, keep an IBC module, and have like an IBC bank connector module or some sort of extension to the bank module.
Well, this kind of goes to questions that I've had that seems to be surfacing right now, which is we're seeing that a lot in a lot of the use cases, like we are seeing patterns where like the staking module must be able to send IBC packets. Or the bank module must be able to send and receive IBC packets. Is the pattern that we think we should have should these be like a third module that sits in between banking and staking, or should we just be extending the bank module interface and the staking module interface and other interfaces to become IBC, to like know about the IBC module?
The reason I prefer extending is because it allows us to keep like strict object capability separation, at least in the Cosmos SDK model. So if we want there to be very limited permissions, like accessible over IBC, the IBC connector between the bank module and the IBC module can only get those permissions from the bank module.
Okay, that sounds, let's try that.
But I do think we will end up wanting to have like batteries included, bank module plus connector, and make sure that's easy to include in zones.
Yeah, that's because it's kind of conceptually difficult for app devs. Like I need this bank thing, and then if I need to do IBC, like I want to do IBC, like I need this shim too. Like why don't we just build that into the bank module as opposed to having a shim? Yeah,
but the problem here is that modules are like a flat namespace when maybe they should be a hierarchy or like a tree or something.
Yeah, there are modules.
Like there's an IBC add-on to the bank module or something. But
yeah, we like as far as like module dependencies, like doing a graph of module dependencies. Like yes, it is more of a tree. I think you're right.
It's a good point. I mean, there are also interesting conversations to be had, which it's maybe a bit premature for, but probably not too premature. as to what are the kinds of things the hub will be doing over IBC in the next few months. Certainly allowing token transfers, maybe the few months after the next few months, but allowing token transfers, some of the interchain collateralization ideas Zaki's been going through are not that difficult to implement as like MVP things.
I think token transfers and interchain collateralization as the MVP use cases would be nice. It seems achievable too.
Yeah.
I think, that would enable an enormous amount. The interchain collateralization stuff is interesting because it sort of expands the surface area of business models for validators, and token transfers are, what we always conceive as the MVP.
What I would like to see for interchain collateralization is a bit more analysis from the security and incentive design standpoints, particularly around like any sort of censorship concerns at the IBC packet level and a quantifying the security that's provided against bribery or collusion to the collateralized chain.
Yep.
Then there could even be a liquid market. Like, how much security do you want to buy? It's just automated over IBC. I want to buy this much security. That'd be cool. You could vary the amount of security you purchase as the amount of assets which are secured by your chain changes, even automatically if you have access to a price oracle. That sounds somewhat terrifying. But
I think it also kind of goes against our sort of validator-centric viewpoint. Like staking pools, like staking pools are as primary actors in sort of deciding like what they should secure.
Yeah, but I would sort of guess that like having both models available at different points within the Cosmos network is okay and compatible.
Yes. Okay.
Cool. Anything
Awesome. Well,
else?
I thought that was a great
last 4
discussion.
minutes.
Do you want some of the pull requests reviewed these 2 weeks? I've done
Yes, particularly 23, 24, 25, and 2 and 3 if you haven't looked already. And if you have not read the IBC architecture document, please read that. It's been merged, but comments are always welcome.
Yeah, I've gone over that. Yeah, okay.
Great.
Is that Raymond there? Did you make it for the rest of the meeting? No, maybe not. All right.
Hope you didn't actually have a fire. Good luck.
Yeah, he had a he had a fire drill at the beginning, so I think we've lost him.
Hopefully it was only a drill.
It's true. All right, everyone. Thank you very much for your time this week. Excellent discussion, and see you all in 2 weeks.
Thanks. Cheers.
See ya.